Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the vertical alignment. The vertical profile of a road would have the level stretches as well as slopes or grades. The vertical alignment consists of the grades and vertical curves, and it influences the vehicle speed, the acceleration and deceleration, the side distances, vertical operation cost, and comfort while traveling at the higher speeds. As you can see from the figure that there is a change in the vertical alignment. That means there are the slopes or grades which actually influences the speed of the vehicle, and it deaccelerates at the rise in the gradient, whereas it accelerates at the sloping gradient, and the stopping distances, side distances, etc. Now the gradients. Gradient is the rate of the rise or fall along the length of the road with respect to the horizontal. It is expressed as a ratio of 1 in n, or also as in percentage. The types of gradients. First, the ruling gradient. Second, the limiting gradient. Third, the exceptional gradient. And lastly, the minimum gradient. The ruling gradient is the maximum gradient within which the designer attempts to design the vertical profile of the road. The ruling gradient is also known as a design gradient, and accordingly, the quantities of the cut and fill are balanced. However, the flatter gradient may be preferred wherever practicable. The selection of the ruling gradient for the purpose of the design is a complex job, as several factors such as the terrain, length of the grade, the speed, the pulling power of the vehicle, and curves are considered. In the hilly roads, it may not be economical or sometimes not even possible to adopt the same gradient because of the large difference in the levels to be covered in a shorter length of the roads. As different vehicles have different values of having powers and carry different amount of load, and in India, due to the consideration, it is to be given to the pulling power of the animal drawn vehicles. Thus, it may not be possible to lay down the precise standards for the ruling gradients. So wherever topography of the place compels adopting steeper gradients, then ruling gradients, limiting gradients are used in view of enormous increase in the cost of the construction roads. With gentler gradients on the hilly road, it may be frequently necessary to exceed the ruling gradient and adopt limiting gradient, but care should be taken to separate such stretches of steep gradients by providing either a level road or either a easier grade. In some extraordinary situations, it may be unavoidable to provide still steeper gradients, at least for shorter stretches, and in such cases, the steeper gradient up to the exceptional gradient may be provided. So here, in the case of the exceptional gradient, it should be strictly limited only for a shorter stretch, not exceeding about 100 meters at a stretch. The maximum length of the ascending gradient which a loaded truck can operate without any undue reduction in the speed is called as the critical length of the grade for the design. From the figure, we have the type of terrains and the ruling gradients, limiting gradients, and exceptional gradients. For the plain and rolling terrain, the mountainous and steep terrain having the elevation more than 3000 meters above the mean sea level, and mountainous and steep terrains having the elevation more than 3000 meters above the mean sea level. Next is the minimum gradient. The minimum gradient on the roads are provided for the drainage purpose. The surface water can be drained off to the side drains by providing the proper camber and certain longitudinal slope, which is essential to drain the water along the side drains. The minimum gradients are 1 in 500 to drain in the concrete drains, 1 in 200 for the inferior drains, and 1 in 100 for the soil drains. The grade compensation on the horizontal curves. So when a sharp horizontal curve is to be introduced on a road which has already maximum permissible gradient, then the gradient should be decreased to compensate for the loss of the tractive efforts due to the curve. And this reduction in the gradient at the horizontal curve is called as the grade compensation. Grade compensation when expressed in percentage is equals to 30 plus R divided by R, which is subjected to a maximum value of 75 upon R, where R is the radius of the circular curve in meters. The grade compensation is not necessary when the gradient is flatter than 4%. Now, the IRC or the Indian Road Congress gave the following specifications for the grade compensation. First, grade compensation is not required for the grades flatter than 4% because the loss of the tractive forces is negligible, and the maximum grade compensation is limited to 75 upon R in percentage. Hence, the compensated gradient will be equals to ruling gradient minus the grade compensation. With this, we shall stop. Thank you.